Myself, Dr. Pushanta Kumar Bardhan, Professor, Department of Mechanical Engineering, GIS College of Engineering, Kollam. My subject topics: Advanced Welding Technology, ME 703A, lecture number 35, Safe Practices in Welding. Safe practices in welding. Safety is a critical consideration for any welding projects. General safety. General safety refers to conditions as they apply to all phases of welding and cutting. Especially it deals with ventilation, clothing, and equipments with electrical connections. Ventilation. Three factors govern the amount of contaminations to which welders may be exposed: dimension of the space, number of welders, possible evolution of hazardous fumes, and management must ensure that welders have proper protection and ventilation. Natural and mechanical ventilation must not be restricted to screen, sufficient to keep concentrations. Mechanical ventilation is required for metals not described here, spaces more than 10,000 cubic feet per welder, rooms with ceiling lower than 16 foot is not allowed, confined spaces or areas with barriers to natural cross ventilation. This is the ventilation. Contaminations goes travel away from the breathing zone. This is a ventilation. This air is coming from this side and going to this side. This is a flow. Travel away from breathing zone. This is fair because from this side air is flowing and another side is passing. This is fair, but this is very good. This is coming and this is going to this place. Here is also another. This air is coming from the top portion and it is going through this to the exhaust. Local exhaust ventilation may be more effective. This is local exhaust ventilation may be more effective. This welding zone, 4 inch to 6 inch from arc or torch, minimum airflow the cubic feet per minute, 150, and duct diameter in 3 inch. 6 inch to 8 inch from arc to torch, 275 cubic feet per minute, and 3.5 inch diameter of duct. 8 inch to 10 inch from arc or torch, 425 cubic feet per minute, 4.5 inch diameter, duct diameter. 10 inch to 12 inch from arc or torch, 600 cubic feet per minute, 5.5 inch duct diameter. This is the exhaust route. This is exhaust route. This welding is being done here, and this is gases are come out from this place to exhaust. Protective clothing is very, very important. This is wooden, this is leather apron. This is sleeves. And this is a leg apron. And this is coat. And this is cape and bib. And this glove is very important. This protective clothing. Woolen clothing is preferable to cotton because it does not ignite as readily or protect the skin better from temperature changes. PPE equipments. These are the equipments for eyes and face. Welding helmet and hand shield or goggles. This is welding helmet and this is goggles. protect from radiation, hot slap, sparks, intense light, irritation, and chemical burns. Wear fire resistance head covering under the helmet where appropriate. Lungs breathing, the respirators. This is a mask protector against the fumes and oxides. Ear and ears and hearing, ear muff, ear plug. This is ear plug, ear protection, protect against nose and ear. Use the fire resistance plug where sparks or spatter may enter the ear. This is feet and hands, the boots and gloves. This is gloves, insulated gloves, and this is for feet, and this is shoes. Protect against the electric shock, heat, and burns. Safety in oxyacetylene welding. Basic rules for oxyacetylene welding ensure safety, fuse plug or disc as is functional. Attach regulator. Stand to one side of regulator. Open cylinder valve slowly, not more than pressure 150 psi. Purge oxygen and acetylene lines. Light the acetylene. Never use oil or grease near oxygen. Do not use oxygen to clean or blow off dirt or clothing. Keep your workplace keep your workplace clean. Gas cylinder safety. Never lift cylinders by the service valve or valve protection. Use sling, net, or other approved means. Number two, keys, handles, and hand wheel must be present. Use the proper regulator. Open acetylene valves no more than 1.5 turn. If in doubt about a cylinder, don't use it. Use protective devices, pressure relief valves, backflow preventers, and check valves. Flashback balusters, fuel gas hose, red, red pipes. This is for acetylene, sometimes black, and oxygen hose. This is always in green. Hose protection required. Pressure reducing regulators are there, must be clean. Gas cylinder storage safety. The storage area must be well ventilated. Keep keep fuel cylinders 20 feet or more from the combustible. Close valves, ensure valves are protected. Limit inside storage to 2000 cubic feet. Store cylinders in the upright positions and secured from falling. Separate oxygen from fuel gas. Testing of leaks, joints and hoses should be checked for leak before any welding is attempted. While acetylene may be detected by its distinct smell, usually at level of less than 2%, oxygen is odorless. Leak detection is best carried out applying a leak, typically 0.5% solution of detergent in water or leak detecting solutions from one of the gas supply companies. On curing the leak, the area should be cleaned to remove the residue from the leak detecting solution. Piping. All pipings and fittings used to convey gases from a central supply system to workstations must withstand a minimum pressure of 150 psi. Oxygen piping can be of black steel, wrought iron, brass, or copper, and only oil-free compounds should be used on oxygen-threaded connections. Piping for acetylene must be of wrought iron. Lighting a torch. First, before you attempt to light the torch, boiling checks. Make sure regulator pressure adjustment screw are backed out. Make sure torch valves are closed. Stand away from front of regulator. Separately and slowly open the oxygen and acetylene cylinder valves. Adjust regulator screws to tip pressure setting. Open or close torch valves separately and fine-tune pressure setting on regulator. Depress cutting lever and adjust pressure if necessary. This is the cutting. This is cutting torch. This is oxyacetylene gas cutting torch. This is the regulator valve for regulating the oxygen or acetylene. Lighting and adjusting the torch with a positive or equal pressure mixture. Separately purge both oxygen and fuel gas lines. Open fuel gas valve by half turn. Ignite flame with striker. Increased fuel gas flow until flame leaves end of tip and no smoke is present. Decrease until flame goes back to the tip. Open oxygen valve and adjust to neutral flame. Depress oxygen lever and make necessary adjustment. Shut down a torch. Shutting down the torch with a positive equal pressure mixture. Close oxygen torch valve. Close fuel gas torch valve. If the torch or regulator and gases are done being used for a while, follow these procedures. Close oxygen and fuel gas cylinder valves. Separate purge oxygen and fuel gas lines. Make sure all regulator gauges read 0. Back out regulator pressure and adjustment screws. If you are using it in a commercial environment, report any damage, etc. to your supervisor. Backfires and flashbacks. Backfires occur when the torch flame into burns into back into the blowpipe. Sometimes it can continue burning back to the point where oxygen and fuel gas are mixed, causing a potentially serious situation. Flashbacks are caused by a reverse flow of oxygen into the fuel gas hose, or fuel gas into the oxygen hose. This then produces an explosive mixture in the hose. This can result in damage or destruction of equipment and could even cause a cylinder to explode. This could end in serious injury or worse, and severe damage to property. Backfire and flashback procedures. After an unsustained backfire in which the flame extinguishes, close the blowpipe control valve, fuel gas first, check the nozzle is tight, check the pressures on regulators, relight the torch using recommended procedures. If the flame continues to burn, close the oxygen valve at the torch to prevent internal burning. Close the acetylene valve at the torch. Close cylinder valves or gas supply points. Isolation valves for both oxygen and acetylene. Close outlet of adjustable pressure regulator by winding out the pressure adjusting screws. Close torch valves. Check nozzle tightness and pressure on regulators. Safety in welding and cutting containers. All containers should be considered unsafe for welding or cutting unless they have been rendered safe or declared safe by a qualified person. Safety in welding and cutting containers. When welding and cutting containers, there is the possibility of explosions, fires, and the release of toxic vapors or fumes. Containers include jacketed vessels, tanks, drums, covered parts, or other equivalent situations. Seemingly empty containers might have material hidden in cracks and crevices, which will release hazardous flame when heated by welding or cutting. And the flammable and explosive material include gasoline, light oil, or many others. This is when welding or cutting a container filled with water to avoid any damage, any serious causes, any firing also. Safety in cutting. Never use a cutting torch where spark will be a hazard. If cutting is to be over a wooden floor, clean the floor and wet it. Keep a fire extinguisher nearby whenever any cutting done. Whenever possible, perform cutting in wide open areas so spark and slag will not become lodged in confined cracks. In plants where a dirty or gassy atmosphere exists, extra precautions should be taken to avoid explosions resulting from electric sparks or open fire during cutting or welding operation. Safety in arc welding. Arc welding includes shielding, metal arc, gas inlet arc, resistance welding. Only general safety measures can be indicated for these areas because the arc welding equipment varies considerably in size and type. Safety practices which are generally common for to all types of arc welding operations. Welding can be safe when sufficient measures are taken to protect yourself and others from potential hazards. Students should read and understand the following before welding: warning labels, do's and don't, material safety, data sheets. Students should also be familiar with the following information: safety in welding and cutting and allied processes, ANSI J 49.1, and Lincoln's electric arc welding safety, that is E205. Flames and gases can be hazardous to your health. Keep your head out of the flames. Use enough ventilation, exhaust at the arc, or, or both to keep fumes and gases from your breathing zone and general area. See product leveling and MSDS for ventilation and respirator requirements. Only manual electrodes holder, which are specially designed for arc welding and cutting and are of a capacity capable of safety handling the maximum rated current required by the electrodes shall be used. In an electrode box, they are indicated the amperage required for the electrodes welding. Any current carrying parts passing through the portion of the holder which the arc welder grips in his hand shall be fully insulated against the maximum voltage. All ground connections shall be inspected to ensure that they are mechanically strong and electrically adequate for the required current, and earthing should be correct to avoid the electric shock. Safety hazards, welding safety hazards. Welding operations present several hazards to both those undertaking the activity and others in the vicinity. Therefore, it is important that you are aware of the risk and hazards welding processes and understand the precautions you can take to protect yourself. Welding safety precautions: always wear appropriate PPE. Welding helmets with side shields. Welding helmets protect you from ultraviolet radiation, particles, debris, hot slag, and chemical burns. Respirator protects you from fumes and oxides that the welding process creates. Fire resistance clothing, ear protection, boots and gloves. During the arc welding processes, live electrical circuits are used to a, create a pool of molten metal. Therefore, when you are at risk of experiencing an electric shock. Electric shock is the most serious hazard posed by the welding and can result in serious injuries and fatalities. You are also at risk of experiencing a secondary electric shock should you touch the parts of a welding or electrode current circuit at the same time as touching the metal you are welding. Noise hazards. When carrying out welding activities, one is likely to be exposed to loud, prolonged noise. A loud noise is considered to be above 85 decibel, and welding activities such as flame cutting and air arc gauging can produce noise level of over 100 decibels, causing damaging to ears and can result in hearing impairment, cause permanent noise-induced hearing loss. Noise-induced hearing loss can have the following side effects: ringing in the ears, known as tinnitus, occasional dizziness, known as vertigo, increased heart rate, increased blood pressure. Exposed to ultraviolet and infrared radiation, looking at the intense bloom of ultraviolet light produced when welding without appropriate personal protective equipment or welding curtains can result in a painful and sometimes long-lasting conditions called arc eye. Many factors can affect the severity of a flash burn injury, such as distance, duration, and angle of penetration. Exposed to ultraviolet and infrared radiation, long-term exposure to arc flashes could also potentially result in cataracts and lead to a loss of vision. Other forms of eye damage include foreign bodies entering the eye, including grit, sparks, and dust, particulate fumes, and gases, which could lead to conjunctivitis. Exposure to fumes and gases. Undertaking welding activities will expose you to invisible gaseous fumes, including ozone, nitrogen oxides, chromium and nickel oxides, carbon monoxide, which can easily penetrate into your lungs. Depending on the gases and fumes, the concentration and duration of your exposure, the resultant damage can be severe. Illnesses caused by welding fumes and gases include pneumonia, regular exposure. Regular exposure to welding fumes and gases can result in a lung infection, which could then develop into pneumonia. Exposure to fumes and gases, occupational asthma, chromium oxides and nickel oxides produced by stainless steel and high nickel alloy welding can both cause asthma, cancer. All welding fumes are internationally considered carcinogenic. Metal fumes fever, welding and hot work on galvanized metal and high steel weld fumes exposure can often result in flu-like symptoms: throat and lung irritation, including throat dryness, tickling of the throat, coughing, and tight chest. Burns. The combination of high temperature, welding arcs, ultraviolet rays, and molten metal means you are susceptible to severe burns when welding. These burns can affect the skin or eyes and can be very serious. They can also happen very quickly. Burns usually occurs when the welder think they can escape taking precautions for a few quick welds. This is bad practice. If you follow guidelines, precautions, you should be able to prevent burns. Welding safety precautions. Ensuring high levels of safety is vital when undertaking any welding activity. Ignoring your personal protective equipment and safe working practices can have serious repercussions and might even lead to fatalities. Therefore, you should follow the safety precautions below to protect yourself at work. Engineering controls. Engineering controls do not eliminate hazards, but rather isolate people from hazards, such as local ventilation at the source of the hazards. Ventilation is very important to remove the toxic gases, other oxides. Administrative control. Administrative control change the way people work. Example include procedural changes, employee training, and installation of signs and warning labels. This is the figure most effective. This is most effective elimination. Personal protective equipment is also very important. Personal protective is the last control and is worn to minimize exposure to a variety of hazards. Personal protective equipment is considered the least effective means of controlling hazards. Examples associated with welding are respirators and flame-resistant clothing. This is the figure how we can control the welding hazards. So this is portion is elimination. Physically remove the hazards. Substitution replace the hazards. That means this tool is by controlling the ventilation and protections. This is the engineering control. This is controlling the hazards. Change the way people work. Administrative control by taking protection on all sides. And this is the last things that protect the worker with personal protective equipment. These personal protective equipment including clothing, goggles or helmet, mask, and also gloves, hand gloves, boots, etc. That should be taken care for controlling the hazards and removing the hazards. Controlling the means controlling the hazards. These are the less effective. This is less effective. So this is very important. Elimination. Elimination physically remove the hazards. So by ventilation, force air or something ventilation, cross ventilation is required to this portion. Substitution replace the hazards with other gases. So oxides may be here. Substitution is replaces the oxides by fruits here. Engineering control is controlling the arcing less gases, equipments, and the electrodes with less fumes. Other controlling administrative control is also changing the way people work, and this is the last protective personal protective equipment. So with this, we conclude the session. Thank you very much. Thank you.